Good morning, everyone. Welcome to DevPulseCon 2020, our first virtual conference. We are honored to host attendees from around the world this year. So I would like to personally welcome those of you who do not speak English as your primary language. So here goes. Please forgive me if I mispronounce things. Namaste, India. Assalamu alaikum to the Middle East, India, Singapore, and Malaysia. Welkom, Netherlands. Shalom, Israel. Halona karibu, Africa. Herzlich willkommen, Germany. Ni hao, China. Hola y buenos días, Mexico. And welcome to the United Kingdom, Australia, and New Zealand. And last but not the least, to my fellow North Americans from the USA and Canada, a very hearty and warm welcome. This is a very strange year, as you all know. We had to postpone our conference from the usual April timeline to October due to COVID. It has given us the time and the resources to bring together a fantastic lineup of keynote speakers, workshops on technical and product management topics, as well as panels on being the sole income earner and finding a path from engineering to product management. And to keep everyone from burning out from all the Zoom sessions and online meetings, we have streamlined 2-hour morning and afternoon sessions. All timings for our sessions for DevPulseCon are Pacific time. I wanted to take this opportunity to mention ThriveWise programs we provide to companies as separate standalone programs. We have our innovative Ally training for engineers and PMs, as well as our groundbreaking Safe Space program, which we are currently piloting at a prestigious Silicon Valley tech company in 2020 and 2021. Both of these new programs are in line with our mission to help improve workplace environments so that technical women can thrive in the workplace. So please do take a look at our programs on our website, thrive-wise.org. That is thrive-wise.org. And once again, welcome to DevPulseCon. Upkar Lidar is a senior software engineer with 10 plus years in IT development, including team management, functional and technical leadership roles, with a deep experience in full stack technology. He is currently focused on machine learning and artificial intelligence and can be seen speaking at various conferences and participating in local tech groups and meetups. Upkar went to graduate school in Canada and currently resides in the United States. Please welcome Upkar Lidar. Thank you, Upkar, for being here, and go ahead with your talk.
Thank you. Yeah, thank you for having me. I'm just going to start a little timer on my phone so I don't go over. But please feel free to interrupt me if it looks like I'm not going to stop talking anytime soon. Hello, everyone. My name is Upkar. Thank you for that kind introduction. I think I need to change that so it doesn't make me sound too old. I think I'm going to remove that 10 plus from the introduction. But thank you. All right, so today I'm here to discuss with you and talk to you about bias in machine learning and artificial intelligence. So I'm not sure who's attending, what the background is for people who are listening. So I'm not going to assume any of that. This is a very light introduction to the topic, but it's a very important topic nevertheless. I've got my Twitter handle on the screen here at the bottom. If you want to be in touch or ask me questions after, feel free to do so. I really enjoy talking about tech and AI and machine learning and make new friends. So that's cool. All right, so today we'll touch on what is fairness, what is bias, and why do these things matter. We'll look at some of the fairness metrics and algorithms that have come up in academia. And then finally, I'll share with you a very specific tool called AI Fairness 360. It's an open source tool that you can use to detect any sort of bias in your machine learning pipelines. And half an hour, it's not enough to go deeper into any one thing on this topic. However, I'll give you enough links and enough resources that if you are interested to learn more, you'll have plenty of resources to do so. Okay, and let me see. I see there's a chat thing, so I'm just opening that, make sure I can see.
Don't worry about the chat.
Okay.
We're gonna curate it and make sure that we have the questions for you at the end of the talk.
Perfect, making it very easy for me. Awesome. Okay, so I don't even think we should ask this question. Why do we care about fairness? We care about fairness because everybody wants to be treated equally. Everybody wants to be treated fairly. With the events that are happening, not just in the United States, but across the world right now, this question has not been of this importance before, I don't think. And the awareness outside of tech is as important as that is. Today, I'm trying to shed a little bit of light into the technology and the models and the data that we are looking at. And as data scientists or as software engineers or just people in tech, we need to ask these questions about whatever code you're writing, whatever solution you're building. So when this whole, we started off with AI and machine learning, and the goal was in some ways to develop these autonomous systems outside of or that operate independently so as to reduce bias in decision making, right? So, but studies have shown, and I think intuitively, we know that that hasn't happened. On the other hand, what's happened is we have taken our intrinsic biases as human beings and put them into these machine learning models and algorithms and actually compounded the problem. So the decision that used to take us a couple of days to make now only takes a couple of seconds. So if you think about bias in that way, what we have done is we have basically scaled up the bias enormously. So the next question you might have is, okay, so we understand there's unfair bias in the society. We all know that. And it shows up in a lot of our machine learning models and algorithms. But how do you define fairness? So there's a very good paper and a YouTube video by Professor, I think he's at Princeton. I need to check this. But his name is Narayanan. And in 2018, he wrote a paper with 21 definitions of fairness. So there's a lot of different ways to look at this concept of fairness and bias in machine learning. The important takeaway from that it was that, first of all, many of these definitions are in conflict. So there's no one way to define fairness. And if you were to pick, depending on which criteria you pick, depending on which metric you pick, you might go away with a different definition of fairness and bias than somebody else, right? And this is really important. I personally think it's a good thing that there are so many different metrics to look at. There are so many different viewpoints and angles to look at this problem because it's a very subjective problem and it affects everybody in a different way. Depending on who you ask about fairness and bias, you might get a different answer on how to quantify it. And at the same time, it's really hard and unfair, I think, to quantify, to quantify this topic into a single number. It does not make sense to me. So I think it's a good thing that we have these different definitions. So I'll give you an example. I think back in 2008 or 2010, two leading researchers found bias when you Google search the image CEO. Only 11% of the top image results for CEO showed women. And at that time, women were actually 27% of US CEOs at the time of the study. Right, so the question immediately is, how do you define? You can tell the study showed that what was showing up was unfair. But then what is the correct number to show? And that's how, that's a good question to ask. That's a good debate to have with all of the stakeholders involved in when you're creating a solution like this. So is 27% the right number to show because that was the percentage of CEOs, women CEOs at the time, or is 50% a better number to show because that is the population of women, in the universe? Yeah, so how you define that, the way you define fairness, the way you define metrics, what metrics you pick impacts bias and impacts how you look for it. Here's another algorithm, right? So if you're in data science, if you're working in this field, you've probably seen this before. There's a company that came up with a solution that came up with this software that was used in Florida. And basically it would predict whether prisoners in Florida are likely to commit another crime if they went on parole, right? And ProPublica came up with this report that showed that the software incorrectly labeled African-American defendants as high risk, nearly twice the rate it mislabeled white defendants, right? But so they showed some unfairness, they showed some bias in the software. The one thing before I move forward, I want to acknowledge it's like I'm showing you one-off cases here. So this is one case where the person on the left was determined as high risk, and later on it was found that person on the right is actually did commit more crimes after being released. This is a one-off case. When you talk about bias, when you talk about unfairness in machine learning, you usually it's a systematic bias, and it's a systematic undermining of a person or a group of people. All right, so that's something to keep in mind. And you can, I've got URLs for the actual report here as well. So when you go and read the report, you can see how they proved that the system overall was unfair and biased. What you don't hear, even if you knew about this Compass case or the software, is that Compass actually tried to eliminate gender and racial bias from the start. So when they developed the system, they looked at something called predictive parity, which basically says how likely is somebody to commit a crime, and what that ratio looks like between white defendants and African-American defendants. And Compass said, hey, we have looked at the ratio between the two groups, and it's approximately equal, and therefore there is no bias. However, ProPublica in their report, they come and say, well, that's one metric to look at bias. Perhaps a more important metric to look at in this case is the rate of false positives. And the rate of false positives for the African-American community was a lot larger, twice the rate that for the white prisoners, right? So again, like I said before, there are different metrics, and based on which ones you look at, you can say if the solution has bias versus it doesn't. And it's very important to actually work with the stakeholders, right? With the prisoners being one of the stakeholders, and the administration being another stakeholder, to determine what is the correct bias to use. And there could be a number of different bias, what is the correct metric to use? And there could be a number of different metrics that you can use. You don't have to rely on just one metric to look at this problem. Here's another example that I'm sure we can all relate to. So this is where you're applying for a job, and the first step might be an AI model of some sort filtering your resume to see if it needs to go to the next level where a human being might take a look at your resume. So this article points out that Amazon had to scrape their AI recruiting tool that showed bias against women. And what if you read the article in detail, what's happening is the model was trained over a 10-year period, but it was trained on resumes which were predominantly coming from men because of the hiring decisions that were made. So you can see there's a feedback loop here where the human bias is feeding more bias into the system in the training data. So the algorithm, because it was trained, it saw that people who are getting accepted into Amazon were primarily men belonging to a certain race, perhaps, and it was penalizing resumes that included words such as women's chess club captain, or if people that were coming from an all-girls school. Amazon tried to remove this bias, but in this case, it was very hard to do so, and they had to scrape the program. But this is, just to show you, this is another example where it's affecting our lives. And I'm sure a lot of us can relate to this example. Here's another one. This is much more recent. This was back in 2019. This is the creator of Ruby on Rails. So a very prominent person in tech. And he's complaining about Apple Card, where him and his wife applied for Apple Card. They have joint property, and so on paper, they are both equally wealthy. They both have same assets and liabilities. However, even despite that, Apple Card, the algorithm gave him 20 times the credit limit that it gave her. And he was confused by this. He didn't understand. He called Apple he didn't call Apple. He called the support, whoever the support is for the credit card, and they weren't able to help him. They said it's the black box. It gives us a number, and that's what we go with. So I want to point out there are two different things here. One is the concept of fairness or bias, and then the second one is the concept of explainability, and they're both equally important. I think of them as the flip side of the coin. So explainability in this case, not only did he claim that the card was biased in some way, but then the fact that the support group could not explain why it came up with the number it did added to the problem. And you can see here at the bottom, Steve Wozniak is reporting a similar problem with his spouse. So again, this is more of a one-off case. Because these people were prominent enough, this started an inquiry inside Apple to see what's happening. But again, I want to go back to the definition where when we talk about bias and fairness, we look at systematic undermining of some group and not just a one-off case. But this was on Twitter, and I thought this was people might be able to relate to this as well. Okay, so with that, I want to share this tool with everybody. It's called AI Fairness 360. It's completely open source. It was built on IBM Research and then donated to open source, but now the community has grown a lot. We have people from other companies and also academia come and contribute back into this framework. I really like what they've done, which is they take these academic papers that come out on bias and basically implement those solutions into the framework. So the toolkit has over 75 fairness metrics. So you use these metrics to determine if there's any bias in your model, and then it has over 10 mitigation algorithms. So once you have detected bias, how do you mitigate that bias? If you've used scikit-learn or in the past, the API that this toolkit follows is very similar to scikit-learn. It's the fit predict paradigm, so it's easy to use if you know that framework. And let me show. Okay, so before we get into the tool, before I do a quick demo of what this tool looks like, let me show you a couple of different ways a couple of different metrics you can use to determine bias. And where does it come from, right? So this is a very typical case of bias where MIT did a study of top facial recognition services. As you can see on the screen here, the algorithm was able to determine the faces of lighter skinned males 99% of the times versus a very, very low accuracy rate for darker skinned females. And I'm trying to remember the name of the person. There's a very good TED talk. MIT grad student Joy did a very good TED talk on the same topic and giving more details about the study. So if you're interested, look her up. That's an amazing talk. There are two different concerns here that I want to bring up. So the first one is oversampling. And again, if you're new to data science, this is where you're sort of making up for lack of data in one class. So there are two different classes here in the training data. There's the blue one, and then there's the orange one. There's not enough orange, and you start duplicating the orange data set to make it equal to the blue one. And the other side of that is undersampling, where you have a lot of data on the blue one again, but instead of duplicating data for the orange, you start taking subsamples of the blue class. And the problem here is that your sample may not represent the variation in data in the original class. So both undersampling and oversampling can introduce bias in your models. Here's another case where you might say, okay, fine. So in this case, we found out there was bias based on maybe the skin color and the gender. So why don't we just drop those attributes? And the problem there is it doesn't really help. There might be other features, proxy features in the data set that closely follow what we call the protected attributes. And so even though you remove the protected attributes, thinking the model will be fair now as it doesn't see color or it doesn't see gender, however, the proxy attributes still gives the model that information. This chart here, or this map here, is from Brooklyn, and this is in 1977, where this is a real thing. Bankers would use this chart and mark out areas in red where they think people living in these areas do not deserve the loan from the bank or do not deserve any help, monetary help from the bank. And it turned out that zip code at the time and even now may identify your race or ethnicity. And so this was a kind of a sneaky way to still introduce bias even though you're not looking at gender or race. So have to be careful about these things. If you're using the tool, which I hope you go take a look, there are a couple of terminology to know. So protected attributes, again, is the attribute like sex, gender, or race, based on which there could be bias in the model. And then fairness metric is what you're measuring in order to measure this bias. A couple of examples of these metrics. So I talked about statistical parity difference, and this is just a ratio of favorable outcomes for a privileged class versus unprivileged class, right? So privileged is class that's getting this undue advantage, and unprivileged is the class that is being biased against. So this is one way of looking at it, is statistical parity difference. And then the other one is equal opportunity difference, where you're looking at your true positive rate, right? So if you look at just favorable versus true positive, you'll get different numbers. So in this case, with the same study, my statistical parity difference is -10 versus my equal opportunity difference shows a little bit more bias of -15. There are other metrics as well. Instead of taking the difference between the ratios, you can take a ratio of the ratio. So in this case, disparate impact is showing the same thing as statistical parity difference, but it's taking a ratio. I know I'm going through this really fast because I only have 30 minutes, but again, the goal here is to give you enough resources to go take a look at this later. All right, within your, when we look at fairness, we look at individual fairness and group fairness. And I thought I had a slide on that, but maybe not. But basically, individual fairness is where you want, you're looking at two people having similar features. If one person is being biased against or differentiated against, versus group fairness, you're looking at groups of people. Within group fairness, you can have two different viewpoints, so to speak. So the first one is what you see is what you get, and the second one is we are all equal. All right, this is how it works. So if the question at hand is, do SAT scores currently compare the abilities of applicants? If you take this viewpoint where you think, yes, SAT score correlates well with future success, and so everybody is on the same level playing field, you can look at these two metrics, the average odds difference and the average odds absolute difference. Versus if you say, no, SAT score may contain some structural intrinsic bias. So based on my background, based on, if my family is low income or medium income, based on that, that will affect how well I'm prepared for SAT. And therefore the SAT score by itself is not a good indicator of future success. Then you might want to take a look at disparate impact and statistical parity difference. Again, depending on the problem at hand and what your viewpoint is, that'll determine what metric you look at. In terms of when to introduce bias detection in your machine learning cycle or project life cycle, there are basically three things you can do. One is you can detect for bias in your data itself. So even before you run any sort of modeling on it, you can see if there's any undersampling, oversampling going on. There are in-process algorithms. So in-process algorithms, if you tell the framework, hey, here are my protected attributes and here's my unprivileged class, the in-processing algorithms, when it's trying to optimize the loss function or reduce the loss function, it's going to penalize more for the unprivileged, for any disparity in the unprivileged group and the the bias group, right? So that's how, while the algorithm or while the model is being trained, you can tell it to be a little bit less strict on the unprivileged group. And then post-processing is, if you don't have access to the data, you don't have access to the model itself, you can still figure out if there's any bias by looking at the output that comes from the model. And then there are different algorithms that you can use to mitigate at that point itself. Now, going from left to right, it's a lot easier to work on this on the raw data itself versus the in-processing algorithm and the post-processing algorithms. So if you can, one of the tips that you'll see later is look at it right in the beginning if you can. But there are 3 different places you can inject some bias detection and mitigation algorithms. Okay, I'm going to skip over a couple of slides. However, I'll share this deck with you so you can go take a look. There's a list of papers that these algorithms were created from or implemented from. This makes for really good bedtime reading. If you want to learn a little bit more about, okay, how did they come up with this metric? What does it mean? Then you can look at the papers itself. I'll give you one example. So reveighing is a pre-processing mitigation technique. So if you have detected bias in your data itself, you can assign weights to the different feature set in order to make them a little bit more equal to each other when the model is being trained. And then some of the models that you work with, for example, in scikit-learn, I think the random forest one takes in weights as one of the parameters when you actually train on your training data. And so you can use this reveighing algorithm to determine those weights to force the training to be a little bit less biased towards your protected attributes. That's just one example, and there are other ones as well. Okay, there's also this debate, this is an important point, between bias and accuracy. And it's important to note here that whenever you try and reduce bias, you'll most likely lose some accuracy as well. And the reason being, if you're reducing bias, you're in some ways changing the weights or changing the data or changing the output, and you're deviating from the true data, right? The actual data on ground. And so that will in turn reduce your accuracy, right? So there's this tug of war between bias and accuracy. And how do you decide what's a good point? Well, there are multiple considerations, right? So first of all, legal. So it's actually illegal in the United States and in a lot of countries around the world to bias based on gender, race, ethnicity, sex, and things like that. So that's why you have to be on top of it. But also there are ethical reasons, right? So based on what your model is doing, so not giving a credit card loan or giving less loan versus if your model is trying to decide whether somebody should stay in jail or leave, those are completely different situations and scenarios, and you have to be cognizant of that. Okay, so I want to show you the toolkit real quick. I have 5 minutes left, and again, I'll share all of this, all of the URLs with you so you can go take a look once I'm done talking. Oops, great. Okay, so I have this GitHub page I'll share with everybody, but this is where I've put in some links, and I want to show you real quick. This is the AI Fairness 360 model homepage. There are tons of documentation, resources. For every mitigation algorithm, you can click on it. It'll take you to the source code. You can see what's going on. And the same thing for metric as well. You can see how they actually calculated these metrics. What I want to show you real quick, they have made this interesting demo. There are 3 different data sets here you can look at. We'll look at the adult income, adult census income. And basically what this is doing, this is a data set from UCI. And given your age, where you're working, your education level, your marital status, occupation, sex, race, gender, those sort of things, based on all of that, this classification model will determine if you're making less than $50,000 a year or more than $50,000 a year, right? So I want to work with that data set, click on next. And now it's checking for bias. It's using the open source AI Fairness 360 toolkit to look for bias. And it tells you very quickly, just based on data itself, it's looking at race as a protected class. And it's saying, well, I've told it race is a protected class. And I think white is the privileged group, non-white is the unprivileged group. And basically it's coming back with statistics that affirm my hypothesis, right? So in this case, there is a, in the statistical parity difference, we want that to be equal to 0, but there is a gap here, as you can see. So the non-white class is being unfairly treated. And you can look at some of the other statistics as well, or metrics as well. If you click on the little hover icon, it tells you what the metric is. Again, we don't have time today, but you can go through this later. So once I've determined, okay, based on race and sex, there is definitely some bias in my data itself, I can look at some mitigation techniques. So I'm going to pick reweighing as a pre-processing mitigation technique. And then if I click on next, it's going to run that reweighing algorithm, come up with weights, and then run the model on my data, retrain my model with the new weights that were determined by this weighing algorithm. And as you can see here, the statistical parity difference went down from -0.18 to -0.1. And then the disparate impact, because it's a ratio, we want it to be as close to 1 as possible. It went up from 0.55 to 0.74. And you can see similar results when looking at sex as a protected attribute as well. So again, this is a pre-done solution or a demo for you to look at. If you go to the resources on this page and tutorials, you can see a bunch of different Jupyter notebooks that they have created. So you know, this tells you how to use the API in your Jupyter notebooks to detect and mitigate bias. So let me put this link in the chat. I think this is the most important one. And then if there are any questions I could answer, I'll be more than happy to do that at this point. I think we have like 2 minutes left.
Yes, we do. Thank you, Upkar. That was a great talk. And right off the bat, I want to ask, since you're on the GitHub page, is there, can you just tell me what the license is for this particular open source tool?
I'll have to go look. I don't know, don't remember it off the top of my head. By the way, they just released also in our API, so you can use that as well.
Cool.
I'm looking for their GitHub page.
Okay, so I have a few questions here. So let me just start off. One of the questions is, why is there a trade-off between accuracy and fairness? And how severe can this trade-off be?
Yeah, so that's a really great question. So as I was pointing out before, as you are reducing, you know, the way this toolkit is reducing bias, and a lot of toolkits work this way, is by changing certain things about the data, right? So it's either by changing the feature set, the training features, or by reconsidering what weights to apply to the different feature set, or it's in model processing by using different penalties for the loss function on your privileged and unprivileged group. But as you can see, you're in some ways changing the reality, and the reality is bias itself, right? So it's not that reality is good or bad. It's just it is what it is. And when you change that to make your model more biased or more fair, the accuracy is still coming from the real data. It's coming from the real training data. And the problem is you're changing that in order to make your model more fair. And that's why there's this gap between, that's why you see the accuracy going down. And the other question people ask is, so how do you know what's a good threshold? So if you go through the notebooks, it actually goes through and shows you with the different charts, how these things, how the accuracy goes down as you're improving your bias. But that comes down to more of a business decision, right? So it's really important as data scientists or computer software engineers, we tend to work in silos. Like we get requirements, we do our thing, and we give the product back. But in this case, it's really, really important to involve the different stakeholders, whoever that may be, right from the start, to determine things like this, to determine how how much of a hit on accuracy you're willing to take, because nobody wants a biased model running in production, but you have to determine how much of a hit I'm going to take on accuracy. And also how do you define bias? It might be different for different stakeholders. How do you define this metric? And at the end, what is the successful criteria for a model to be fair, right? So all these are very subjective questions that you need to get together with the stakeholders and discuss up front. That's a good question, though.
That's so piggybacking on what you just mentioned about bringing in the stakeholders. As a developer, what would you recommend developers do? Like, what process would developers think about following to pull in stakeholders? Let's say I'm working on a piece of software that I seriously think is going to create a bunch of bias, and I want to make sure that people who have a say know my thoughts and know that this needs to be looked at more carefully before we ship a product or ship a particular feature. What would you recommend that as developers we can do to at least get involvement from higher layers, senior leadership, whether it's PM, whether it's on the technical ladder? What things would you recommend that we could do?
Right. So I think this is more of a people problem, less of a tech problem. And one thing that try and figure out what matters to them, right? So for a PM or for a senior leadership, it might be a matter of, what you're creating might not even be legal, and that can result in consequences after somebody starts using your software. Then there are, like I was saying before, there are ethical issues and trust issues. Maybe you lean a little bit more on that than the technical metrics by themselves. If you give them examples of how Amazon has to, the examples I was giving earlier and what that resulted in for these companies, I think that would be a really good driving factor to consider fairness and bias in your solution. In addition to that, fairness and bias almost always is an afterthought. And so if you can work with your teams to, to make it a checkpoint in your release, right? Did you check for bias in your model? Did you check for fairness? And what did that look like? What did you come up with? That should be a release criteria, just like integration testing or unit testing. It should not be an after fact. So I think as a developer, you obviously have some say in what goes into the product, but it's really hard to do it by yourself. So I think it's important to have that consensus in the team and educate them, right? So that's what we're doing today. Hopefully this gives you some idea of, we all know about bias. We all know that, the systems we work with are unfair, but to be able to quantify it in this way is very important, and I think will help with what you were asking.
That's a really good point. And I think maybe as a follow-up talk, we could ask you to do a talk on how we can use this tool as developers to quantify, so that we can present things to senior leadership or to, the PM ladder to, back up our case, so to speak.
Yeah, absolutely. Again, thank you for having me here today. I know half an hour just does not justify, it's very hard to go into details on any of these topics, and that's why I just flew through the slides. But you have my email and you have my Twitter handle. If you have any questions or want to have a discussion, I'm open to that.
Awesome. Thank you so much, Upkar. And one last thing is, Upkar mentioned Joy, who is affiliated with MIT. I think she's a professor at MIT. Her name is Joy, Joy. Her last name is Bolamwini. Just Google her. You'll find her. She's big in algorithms and bias. So thank you so much, Upkar. It was a pleasure to have you. A great talk. Thank you.
Thank you. Bye-bye.
Bye. And we have a mailing list, which is, I'm just going to say it out. I posted it on chat as well. It's tinyurl.com/TW. TW is for ThriveWise. So TW-member-signup. Pretty easy to remember. So tinyurl.com/TW-member-signup. So please sign up for that, and so you can start getting our monthly newsletter. We do a COVID bulletin. We do not spam. We don't do too many announcements, but we will be sharing when we are uploading all our recordings from all our morning sessions at DevPulseCon via email. So it's important to sign up if you want to know when the recordings are published and where the location is. All right. And I think that's all I've got right now.